Math Conquerors, and welcome back to lesson 8-7. This is part 2. We're on page 511, example 2. 3x squared minus 17x plus 20. In this trinomial, a is equal to 3, b is equal to a negative 17, and c is equal to 20. Since b is negative, m plus p will be negative. Since c is positive, m times p will be positive. Okay, so let's look at that. First, we have to multiply 3 times 20, which is going to give me 60. Now, I need a negative times a negative. That will give me 60 when I multiply. And when I add, I will get 17. And so I'm going to use 5 and 12. Now remember, when I group down here, I want to use things that can factor together. So the 12 should go with the 3, and the 5 should go with the 20. So that when I rewrite it, I have 3x squared, minus 12x plus minus 5x plus 20. Now I need to factor. I'm going to factor out a 3x, leaving me with x minus 4. I'm going to factor out a negative 5, which would leave me with x minus 4. And then I just need to group this together. So I have 3x minus 5 times x minus 4. 4. Okay? All right, let's look at our guided practice. And it reads 2n squared minus n minus 1. So I need to multiply 2 times 1, which gives me 2. So I need something that when I multiply it, I get 2, but when I subtract it, I get a negative, okay? So that's going to be 2 and 1. Now again, I want to put things together that I can factor. So I'm going to put the negative 2 with the 2n. So I have 2n squared minus 2n times, well, plus, and this is a positive, so n minus 1. What can I factor out of here? I can take out a 2n, leaving me with n minus 1, plus, there's nothing to factor out of here, n minus 1, but it does give me a common. Now, remember in algebra, there is an understood 1 here. Do not put a 0, okay? So it's going to be 2n plus our understood 1 times n minus 1. Okay, let's look at 2b. 10y squared minus 35y plus 30. Well, the first thing I see is I need to pull out or factor out a 5 to make this simpler to work with. We talked about that in a previous problem. So I'm going to pull out a 5, leaving me with 2y squared minus 7y plus 6. Let's make this look more like a square, because that makes my problem much simpler to work with. So now I need to say 2 times 6 is 12. And it's going to be a negative and a negative. And I need it to give me, sorry, this is supposed to, yeah, this is supposed to be 7. Okay, so we need two numbers. When we multiply them together, we get 12, but when we subtract them together, or basically add them together, I get 7, which would be 4 and 3. And again, I want to group those with like terms. So I'm going to say 5 times 2y squared minus 3y plus negative 4y plus 6. Okay, out of this, I'm going to pull out a y. I'm going to use some brackets here, which would leave me with 2y minus 3. And then here, I'm going to pull out a negative 2, which would leave me with 2y minus 3. And then ultimately, that is going to give me 5 times y minus 2 times 2y minus 3. Okay, let's look on page 512, and we have a new term, prime polynomial. A polynomial that cannot be written as a product of two polynomials with integral coefficients is called a prime polynomial. So if we cannot find any factors that when I put them together, they give me the answer I'm looking for, this is a prime polynomial. So let's look at an example. Here I need to multiply my 4 times my 5, or my a times my c, and a times c is going to give me 20. So I know that both of these need to be negative, and when I put them together I get a negative 3. And the factors of 20 are 20 and 1, which would be a negative 21. Well, that's not going to give me a negative 3. Negative 4 and negative 5, which is going to give me a negative 9. That will not work. A negative 2 and a negative 10, which will give me a negative 12. That also will not work. And I am out of factors. There are no more factors for 20. So if I have exhausted all of my factors for 20, and I have not found a factor or something that will work for my polynomial, the polynomial is considered a prime polynomial. So this polynomial is prime. It cannot be factored. It is in the lowest form that it can go. For example, remember our numbers 2, 5, 7. Those were all prime numbers. There's nothing that you can get out of a 2 except a 1. 1 times 2, and that's it. It is a prime number. 1 times 5, that's it. 1 times 7, that's it. 13 is a prime number. Well, you can have a prime polynomial. Okay, let's look at guided practice 3a. And we have 4r squared minus r plus 7. So 4 times 7 is going to be 28. I need two negatives. When I put them together, I'm going to get a negative 1. So if I think of this, I'm going to have 1 and 28, which is going to give me a negative 29. Well, that's not going to work. And then I can have 2 and 14, and that would give me 16. That's not going to work. And I can have a 4 and a 7, and that's going to give me a negative 11. And there are not any more factors for 28. Make sure that you've exhausted all of your factors before you decide that it's prime. Once you've exhausted all of your factors and the way that it can be worked out, then you can consider this a prime polynomial. Okay, let's look at 3b. 2x squared plus 3x minus 5. Now, first we have to say a times c, which is 10. And I know in this case it's going to be a positive and a negative, with the positive being the larger number. So 10 and 1 would give me a 9. That will not work. And let's see, I can also use 5 and 2, which will give me a 3. So I have found something that will work. Now I want to put things together that can be factored. So I'm going to put the 2 with the 2 and the 5 with the 5. So remember my formula. It says 2x squared minus 2x plus 5x minus 5. Don't forget your formula. Okay, I'm going to take out a 2 here, 2x, leaving with x minus 1. I'm going to take out a 5 here, leaving with x minus 1. And I have found my common ground here. And so this can be written as 2x plus 5 times x minus 1. This is not a prime polynomial. I exhausted all of my factors, but the 5 and the 2 did work.